Hello, everyone. Welcome to another episode of Practice Exam Review. Today, we're doing problem 14. So, from the question, we're first going to write down some of the probabilities that the question presented. So, first, it says from collected data, 1 in 100 men have prostate cancer. So, if C denotes whether a person have cancer, so C is if a person has cancer. What we've just learned is the probability of somebody having cancer is 0.01. Right. Cool. And then it says your test has a 95% accuracy rate for correctly identifying individuals with prostate cancer. So now we've introduced another random variable, which is T, that says essentially whether your test tests positive. And then from that information, we just got given someone have cancer, then 95% accuracy rate is a probability that your test is positive, right? And then it says it has a 90% accuracy rate for correctly identifying individuals without prostate cancer. So given someone does not have cancer, and then your test is a 90% accuracy rate for correctly identifying individuals without them. So the test is negative because it correctly identified individuals without cancer. And the accuracy rate for this is 0.9. And now, what are we trying to find? We're trying to find the probability where, given someone tested positive for cancer, what is the probability that someone actually has cancer? So we want to find given someone tested positive, what is the probability of someone actually have cancer? Okay, so writing down in probability notation all of the probabilities that you already know and the probability that you're trying to find is very helpful. So now the answer is not completely apparent just by looking at the question, but this might remind you of something called the Bayes rule, right? So if you're not completely sure, then we know that we're trying to find the probability of C equals 1 given T equals 1. And while we already have some sort of notion or knowledge about the opposite, which is the probability of T equals 1 given C equals 1, and that should ring a bell for the Bayes rule. And now, what is the Bayes rule, right? So if we're trying to find the probability of this, then we remember from Bayes rule that this is equal to the probability of T equals 1 given C equals 1, which is the converse or the opposite, times the probability of C equals 1 divided by the probability of T equals 1. And this makes sense because the result of this times this, as you probably remember from lecture, is the probability of your testing positive and this person has cancer. And now you're dividing by the probability where you're given that the test is positive. Okay, so this value, we already know this value. It's here, 0.05. And now, do we know the probability if a person is going to actually have cancer? Yes, it's 0.01. So, are we able to find the probability that the test is positive from all of the information above? And realized we do, because the probability of T equals 1 is equal to the probability of T equals 1 given C equals 1 times the probability of C equals 0, plus the probability of T equals 1 given C equals 1 times the probability of C equals 1, right? Because these are the only two scenarios that would happen, right? So the test is positive either we're given somebody does not have cancer, or the test is positive given someone actually has cancer. So then we multiply it by C equals 0, and here we multiply by C equals 1, and ultimately the summation gives us the ultimate probability of when the test is positive. And we know this by doing 1 minus 0.95 here, right? Times the probability of C equals 0. And we know that just by doing 1 minus 0.01. And this is just what's here. So 0.95 times, we already know this from here as well. So 0.01. Cool. And this should just be 0.05 times 0.99 plus 0.95 times 0.01. So this, we got the probability of t is equal to 0. So in order to find the probability of c equals 1 given t equals 1, then we just substitute everything back in. So 0.95 times 0.01 divided by everything that we have here. So 0.05 times 0.99 plus 0.95 times 0.01. And this should gives you roughly 0.0876. And that is our final answer.